Hey, 8th grade science, how you doing? I hope you're having a good day. We're going to get started talking about lightning. So last time we talked about really thunderstorm formation and really the beginning and the cloud and how it works. Now we're going to talk about lightning and thunder just a little bit today. So let's get started. Your first word is chair. Okay, first word is chair. So as we begin talking about lightning, hopefully you all know what it is. It's one of the best known features of a storm. Like if you ask someone when they think of, well, a thunderstorm, it has the word thunder right in it. But when you talk about it or think about it, right, you're thinking, oh yeah, lightning and thunder kind of goes with rain, okay? So what lightning is, the definition for it, it is an abrupt discharge of electricity through the air that produces a flash of light, okay? An abrupt discharge of electricity through the air that produces a flash of light, okay? And we all kind of know that if there's a lightning strike, it's going to be a flash through the air, and it lasts a very short amount of time usually. So just some stats, there's 100 strikes every second, and there's about 44 deaths a year from lightning in the United States. There's more injuries and things like that, but just specifically deaths from lightning. So how is lightning formed? Great question. Well, so what happens, I think I talked about it Friday in the slideshow, is that there's a buildup of static electricity in the cloud from the water and ice molecules colliding. And so when that's all colliding, right, if you rub a balloon on your hair, if you have hair, I don't, so if you rub a balloon, it's going to cause friction, okay, and that builds up static electricity. Well, just like sometimes you end up touching a metal object and it shocks you, that's a release of static electricity. And so there is static electricity building up in the cloud. And what happens is, as the static electricity is building up, the negative charged ions build on the bottom of the cloud and the positive on the top. And I'll share a screen in a little bit that'll show that. As the cloud is moving from the wind pushing it, the negative charge at the bottom is just building up, getting stronger and stronger. And there's a lot of air, obviously, keeping the negative ions apart, but the ground is positively charged. So as the cloud comes over an area that has a positive charge underneath and the cloud's negative charge is building, eventually the air can't keep them separate, okay? And so then what's going to happen, because opposites attract, the negative charge is going to go down and the positive charge is going to come up a little bit, and then they're going to connect, and it's going to cause that lightning strike to be completed. So what happens is it's a stream of electrons that are negatively charged, and they come out from the cloud, and then they're going to the ground, obviously. And then there's going to be a little bit of a positive charge coming up from the ground to meet that. And so we're going to talk a little bit about specific names for these streams of electrons, okay? So here we go. I have a couple different images I'll show you guys eventually. Let's look at this one. Let's start with this one, okay? So imagine our cloud is up here above the numbers, okay? The first thing is a stepped leader, okay? A stepped leader. Now the stepped leader is just it's a stream of electrons that are coming out from the cloud towards the ground. And so electrons are negatively charged. So it's a negative charge stream that is going towards the ground because the ground is positively charged, and it has jerky movements, as we see. It's not a straight line down, right? It kind of like ba 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 ba. Okay. At the same time that's happening, we have this positive stream of protons coming up, which is called a positive streamer. Okay, so we have a stepped leader coming from the cloud towards the ground. At the same time, we have a positive streamer coming from the ground towards the cloud. Eventually, they will connect, and it's generally about 100 feet above ground that they connect. And that is what causes that, that bright light that we see. Before that, it's not really that bright, right? We can't see it that much, but when they connect, it causes what's called a return stroke. And that is the very bright flash of light that we can see. So let me just review it real quick. So stepped leader is gonna be a stream of electrons coming from the cloud towards the ground that moves jaggedly, okay? Not in straight movements, jerkily. A positive streamer is a stream of protons coming from the ground towards the cloud, okay? That's gonna eventually connect to the stepped leader. And they connect about 100 feet above ground. And then we will have our return stroke, which is an upward flow of positive charge to the cloud. So here we see our stepped leader coming down, our positive streamer coming up. When they connect, it's going to look like this, right? So we have our negative charges and our positive charge. Well, what happens for the return stroke to happen, all of the positive charge goes up towards the cloud. And that is called the return stroke. And that is what causes the bright light. It lasts about 1/millionth or 2/millionths of a second, but it has about 2 trillion watts of energy in that short amount of time. So when we have all of that energy, it's going to cause the air around it to heat up really hot. And how hot, you ask? Well, it can cause it to heat up to 54,000 degrees Fahrenheit directly around the lightning. So 54,000 degrees Fahrenheit. When you think about the air temperature going that hot in that short amount of time, it causes the air to expand, right? We talk, when things heat up, they expand. When things cool down, they decrease in size, with the opposite of expand. I can't think of what word I want, but anyway, so when it heats up to 54,000 degrees Fahrenheit, it's going to cause a quick expansion. And when air expands that fast, it causes a really loud sound, sends a shock wave, and that is what we hear as thunder. So thunder is caused by the heating of air from lightning so fast, and it sends out a shock wave. 54,000 degrees Fahrenheit, for example, of how hot that is about 5 times the temperature of the sun, which is pretty crazy to me. Let's look at another example. Okay, so here you see within the cloud, right, I said about friction giving charge to the cloud, the negative molecules coming down and the positive going up. Okay, and then we see here a stepped leader coming down, our positive streamer coming up, and eventually it connecting, and then we would have our positive charge going up towards the cloud in what's called a return stroke. Well, one other part to the lightning strike is called a dart leader, and that happens after the connection is made. So you'll see these two are connected. It's just more negative charged ions coming down, and basically it's using the same pathway, and it causes like that flickering of light that we see sometimes. Instead of it just being like a one-time like kind of thing, flash of light, whenever it goes down and it's kind of flickers, that is the dart leader effect when it comes down afterwards. So the reason that Dart leader happens is because there's still so much electrical energy in the cloud that it has more to release. And again, there's already a channel of connection. So the negative is going to end up going down, and it's much faster. And like I said, it's that flickering that we get from a light bulb. That is our Dart leader. I already talked about thunder, so we're good there. Again, thunder is caused by the heating of the air around the lightning so fast that it causes a shock wave, and we hear that sound. We can hear it up to 10 miles away. And so the speed of light and the speed of sound are different, right? The speed of light is faster than the speed of sound. So whenever there's lightning, we always hear the lightning first, and then, or sorry, we always see the lightning first, and then hear the sound second, hear the thunder second. That's what allows us to be able to calculate how far is the storm or the lightning away from us. The way we can do that is you see the lightning, immediately start counting, and then when you hear the thunder, stop. So if I would see lightning, I would say 1, 2, 3, 4, 5, whatever. And then however many seconds, divide that by 5 to get how many miles away it is, or divide it by 3 to get how many kilometers away it is. Okay? So if you count to 10, if there's 10 seconds between lightning and the thunder that you hear, then you would get to 10, you would divide it by 5, and you would find out that the storm is 2 miles away from you. Okay, so just a little trick you can do. For the last part of this lesson, we're just going to talk about the different types. Oh, actually, I have one other animation to show you. So here's kind of how a stepped leader would come down in slow motion, right? All the negative charge, it would stop there. Positive would come up, and it makes a connection. The positive flows up to the cloud, causing that bright light that really the main part of the lightning. Okay, and so now we're going to talk about different lightning strikes. So the one we had been talking about is called a negative cloud to ground. So that's this one right here. We have a negative strike going from the negative part of the cloud to the ground. Okay, it's simple. That's what we talked about. Most common one that we would see. We could also have a positive cloud to ground. That would be if there's a lightning strike from the positive upper part of the cloud to the negative part, to a negative part of the ground. And so this one's a little more dangerous because it has more energy coming from it. It's a stronger energy, and it can strike negative ground that's up to 10 miles away from the cloud. So negative cloud to ground is from the negative cloud to the positive ground. Positive cloud to ground is from the upper positive part of the cloud to the negative part of the ground. There's also what is called hot lightning, which comes negative to positive, but the lightning strike itself isn't hotter. It's just that it is more likely to cause a fire. So normal lightning is cold lightning, just because it doesn't start fires. And then we have our hot lightning, which the reason that it's more likely to cause a fire is because there is more electricity through the current. So the strike happens in hot lightning, but then afterward, there's some pulses of electricity followed by a steady stream. And so it lasts, a lot longer than regular lightning, but it's still usually less than a second. And that's the lightning that is more likely to cause fires. There's also a rare kind that is ground to cloud. So it would be from the ground to the cloud. And that's rare. It only really happens from really tall towers or mountains that are closer to the ground. And if there's too much energy on the object, then that'll shoot up to the cloud. Finally, we have cloud to cloud. And cloud to cloud can either happen from one cloud to another. So we go boom to boom, okay, or boom to boom. It can also be from the same cloud to the same cloud, just the lower part to the upper part. Now, cloud to cloud is the pretty lightning that we would see over the summer, what we would call heat lightning sometimes, or sheet lightning. Because it happens up just in the clouds, and it's happening usually sideways or whatever, up in the upper atmosphere, it gets a chance to reflect or reflect the light from the sun, which causes the whole sky to light up usually. So over the summer, when you see heat lightning, that is cloud to cloud. And there's a lot of times there is no thunder with it because it's so far away. So just remember, now you kind of be able to tell, oh, that's cloud to cloud lightning in the summer, heat lightning. And you'll know why it happens, because the lightning in the sky is reflecting the light from the sun, causing it to light up the whole sky. That is all I have for you. Hopefully now you know a little bit more about lightning. Your second word is going to be seat. Okay, second word is seat. I hope you have a great day.